So some of the take-home messages throughout the whole day, you heard about all these materials. The few types that we're going to continue on with, which are you going to cover kind of the few that we're going to...
Tentative.
Yeah. So the advancing materials that we're going with basically perform similar to or better than petroleum plastic containers for plant growth. These soy protein composites, especially with PLA, not PHA, release plant available nutrients and can basically, you can save a lot of fertilizer by using these containers. Like I mentioned before, the PLA with 20% lignin was basically identical to a petroleum plastic container. Growers will not have to change their cultural practices. They can feed the same, grow the plants the same, and they basically look the same as a conventional plastic container. Both water use efficiency and container integrity were increased by the polyurethane coatings. The containers lasted much longer on the bottom of the pots especially, and water use was definitely enhanced, so the plants were able to use water more efficiently with a coating on those paper fiber pots. I didn't really talk about PHA composites a lot, but one thing we noticed, I'll go back to one of these first slides. Here, except for this cellulose mixture, all these were lower than the petroleum containers, but one thing that we've figured out is if you feed those at a slightly higher rate, they will perform just as well, and they can still degrade in the soil. And then one thing that it's still really up in the air is this interaction between the nutrient release of these soy composites with PLA and the microbes. We speculate that this nutrient release is because of microbes breaking down the soy and liberating it so the plants can uptake these nutrients. But there still needs to be some work that should go into looking into that more in depth. So some upcoming trials that we plan on doing. I want to do a root zone fungicide bactericide drench, something similar to what growers do right after they transplant. Typically growers will apply some type of root zone fungicide just for preventive measures. What I want to know is, will that negatively impact the microbes that do break down these soy containers and basically reduce this beneficial fertilizer effect that we're seeing? And also, how does it impact container integrity? So if your container is breaking down too fast and you apply one of these common chemicals used to impede microorganisms, how will that impact how the containers hold up as well? Like I'd mentioned with the paper fiber and the polyurethane coating, one thing I thought about was, yeah, we did 2 coats, but what if we just soak these pots in this dispersion for a longer period of time and then pull them out and dry them instead of doing 2 coats? Will coating these with polyurethane and submerging them for a longer time replace the need for 2 coats? Another thing that we have not done is produced any plant container units in shuttle trays. Shuttle trays are used everywhere throughout the industry. So one thing we want to look at is how container aesthetics and durability are impacted by growing in shuttle trays. And this trial is actually probably going to be combined with this one, so more grower focused, that type of thing. Another thing I've thought about recently is cultural practices. So we all know there's wet growers, there's dry growers, everywhere in between. How does your irrigation management impact this nutrient release from these soy containers? So will a wet grower benefit more from beneficial nutrient release than a dry grower because of enhanced microbial activity? These are all a bunch of questions that we want to answer. So when we get to this, the 3rd year, hopefully when we collaborate with the industry, we can get a lot more containers and do some of these more in-depth tests with this specific fertilizer release of these containers. That or root zone moisture percentage, that type of thing. So keeping things at a drier environment versus someone that saturates pots all the time. Like there's been controversy over growing poinsettias wetter now versus drier. So I just want to know how specific root zone moisture concentrations will impact this nutrient release. So with that, I want to thank everyone for coming today. Thanks for listening. And are there any questions?